Hi students, in this lecture episode we shall be considering the topic calculus, and calculus is a broad topic that comprises of two parts. And the first part of calculus talks about differentiation, and the second part of calculus talks about integration. So basically we have the aspect of differentiation. Then we have the aspect of what? Integration. So we examine from these two areas the concept of differentiation and the concept of integration. You examine from these two areas in your exam, your WAEC exam, according to what we have in the scheme of work for your class. So that means that you have to be very, very good in solving problems from differentiation, and you must also be very, very good in solving problems from integration. Alright, so this very episode we are going to start examining the concept of differentiation, and in subsequent episodes we shall move over to the concept of integration. Now, differentiation is not a concept that is actually very difficult. It's just something that requires a lot of understanding, and calculus generally is not a difficult concept, but it's just that it requires your understanding. So whenever you are studying the concept of calculus or taking lectures on calculus, you have to be very, very attentive so that you can understand each and everything we are talking about in the concept of calculus. And you see that when you are able to do that, your questions becomes a piece of cake for you and you enjoy them. Alright, so moving on, the first thing we shall be talking about is the meaning of functions. Now, you always come across the word functions when working with calculus problems. You always come across the word functions. And functions simply is a word that is used to describe the dependence of one variable on another variable. So it describes a relationship whereby one particular variable relates with directly or depends on another variable. Okay, now this relationship, from our knowledge of variation, whenever two variables are related to each other, it may not be necessarily a direct variation. It could also be an inverse variation. So if we are bringing that into the idea of functions here, probably we may also be having something like that, but particularly what we shall be describing here is just the relationship between one variable and the other variable. Hope that's clear. Right, now you see things like this: y equals to 2x plus 3x squared. Now when you see something like this, what does this mean? This means that this variable which you have on the left hand side, y, depends on the other variables which we have on the right hand side, which is x. So what we have on the left hand side, rather y, depends on what we have on the right hand side, x. Good. Now how does this mean, or how does this work? Now you see that, for example, if we are to give x a value of 2, that y can only take its value when x have been given a value. Yes, and the value y we eventually take depends on how big or small the value x is. Now if x is 2 rather, this simply means that y got 2 times 2 plus 3 plus 3 times 2 squared. So when you do this mathematics, you come up with a value for y. Now what do you conclude like this? You can say that, y depends on what? The fact that x was 2. Now assuming we made x to be 3, you can say that the value of y will increase, or if we made x to be 1, if we make s to be 1 rather, the value of y will reduce. So you can see that y depends on the value of x. So we can call this a function such that y depends on what? X. A function whereby y depends on x. Now this is the basic concept from which calculus is drawn out from. So we try to find out in a relationship called dy over the x. Dy over the x is something something similar to when we are saying change in y over change in x. So if we are trying to consider the rate of change of how y changes when x is changing, so how is it that y will be affected by the changes that are brought about on the x variable? So when we try to study this relationship of change, we call it dy dx, and it's spelled this way: d spelled dy dx. So the concept of dy dx simply talks about the study of the change that occurs in one variable which is on the left hand side, how it relates to the change that occur on the other variable which is on the right hand side. And most of the time we always have our y on the left hand side and we have our x variable on the right hand side. Now you have to know that calculus does not just only work with y and x. We could also have a situation where we are having dt over the x ds or ds over dt. Yes, we could be having the dt over the x or dx over du. So how do we know which of them we are going to be having in our calculus problem? Now take a look at your function or the equation given to you. If in your equation rather, you have t on the left hand side and then you have the variable x on your right hand side, then it means that your differentiation is going to be what? dt over dx. For example, if you are giving something like this, t equals to 5x squared. So when you are differentiating this function, it's going to be what? dt over dx, simply because we have t on the left hand side and we have what? X on the right hand side. So that's how differentiation works. This is the way that's how we write the expression for our differentiation: dt over the x, dy over the x, or d whatsoever over d whatsoever. Let's just put it that way. All right, now that's the way we represent that. Now moving on to the standard method of differentiation. So how do you actually evaluate the y over the x? So if for example now we are given, for example, an expression like this: y equals to 3x raised to the power of 5, and you are asked to differentiate y with respect to x. Now this is another way you can say it. Dy over the x simply means find the derivative of y with respect to what? X, or differentiate y with respect to s. At times you may see them write it like this: WROT. This means what? With respect to. WROTX means with respect to what? To x. Alright, good. Now that is that for that. So differentiating this, it works with the standard formula. And this is standard formula. The standard formula goes like this: if y equals to axn, it says that dy over the x will be what? A times n x raised to the power of what? N minus 1. So we can put this in a bracket, and this means that whenever we are going to differentiate what we have on the left hand side with respect to what we have on the right hand side, now a stands for constant and n. A constant is a number, not a variable. So the constant a and the constant n. So we say we multiply this constant, which is the coefficient of x, by the constant, which is the power of x. We multiply it and it gives us a value, and then we put s in a bracket, and then we subtract 1 from the power of x. That is the solution to our question. We have differentiated it. Good. So that means if we are given for our expression now, which says y equals to 3x raised to the power of what? Of 5, it means that if we are to find dy over the x for that expression, it will be what? This, let me write it here again: 3x raised to the power of 5. So it will be what? 3 times 5, that will be what? 15. In our bracket we still have our variable x, and the power this time around becomes 5 minus 1. 5 minus 1. So our differential, or our result of our differentiation is what? 15x raised to the power of 4. We have differentiated it, so we can say dy over the x is equal to what? 15x raised to the power of 4. Now this is how we differentiate. So it's this easy actually. This is how we differentiate it. This is easy, just for you to understand this. Now this is the basic fundamental concept you have to understand. Once you understand this and you grab this and you practice solving some problems with it, and it sticks to the tips of your fingers, you see that you no longer have issues solving this kind of questions. And when we move into other complex concepts, you discover also that it's also something similar and easy also, and eventually you see yourself solving calculus problems like a pro. Alright, so now we are going to have another expression. This expression says y equals to what? 14x squared. Now if y is equal to 14x squared, differentiate y with respect to x. I believe you want to pause this video now and solve this to see if you get it. Alright, so if you are done with that, we can do the solution together. Now dy over dx will be what? 14 times 2. 40 times 2, that gives us 28. We repeat our variable and we subtract 1 from the power. As simple as that. So our answer gives us what? Our answer eventually becomes 28x raised to the power of what? 1, or simply 28x. Good. Now we can then solve another question. Now this question says y is equal to 10. Find dy over dx. Now this is a unique question. Why? Because you can see that we do not have any variable on the right hand side. We only have a variable on the left hand side. So what are we going to do? We go back to our concept of indices. Now we can decide to put any variable we like on the right hand side and give it the power of 0. That simply means that is because whenever we have a constant is a number. Maybe a constant like 5 is a number that has any variable you feel like attaching to it, whether a or b or c, but that variable carries the power of 0. Yes, simply because anything raised to the power of 0 gives 1. So when you eventually multiply that 1 by that constant, it gives you the same constant. So that means that any constant I see, I can attach any variable I like to the constant. And then I give it the power of 0. So let's assume we are attaching u to this constant. So u takes the power of 0. So we are going to differentiate this by saying the what? Y over du, not dy over the x, because our variable on the right hand side is not x, it's u. So now if our variable now is what? Is x, it means that our differentiation is going to change to what? Dy over dx. And what will be the value? What will be the answer for our dy over the x? Our dy over the x will give us what? The power of x is 0, so 10 times 0 gives what? 0. And then we repeat our variable and we subtract 1 from the power. That gives what? Minus 1. Now this minus 1 here is no longer really important because 0 cancels everything. So when we say 0 times whatever, it gives us 0. So it means that the answer to this differentiation is actually going to be what? It's going to be 0. You can see it. Now if you do this for another constant, for example y equals to 20, so let's now add a variable of what? T, and we say dy over dt. Dy over dt will be what? 20 times 0, because the power of t is 0, that gives 0. We repeat our t and then we say 0 minus 1. Okay, so eventually this will be what? T raised to the power of minus 1, and everything will sum up, we wrap up to give us what? 0. So we say dy over dt equals to 0. So from this, what do we conclude? We conclude therefore that whenever we differentiate a constant, we always have 0. So just keep this in mind. This is the second thing to keep in mind. The first thing is to keep the formula for the general method of differentiation, and the second thing to keep in mind is the fact that whenever we differentiate a constant, it gives us a 0. So if you are given an expression now, you are given a function like this, y equals to 3x squared plus 6x minus 0. Okay, no, not 0, minus 15. And you have to differentiate it. So you simply take it one after the other. dy over the x will give us what? So you differentiate this first. And when you differentiate that, it gives us what? 3 times 2 is 6. And subtract 1 from the power, it gives us what? 1 left. Hope you understand that. Just individual differentiation, that's what we are doing now. So we say 3 times 2 gives us 6, and then we subtract 1 from the power. That leaves us with what? X raised to the power of 1. Hope that's clear. We move to the next part and we say 6 times what? The power is what? 1. That gives 6. because the power to x here is 1, right? Yes, it's 1, because s raised power of 1 is 1, right? So now see, we subtract 1 from this power, 1 minus 1, that gives 0. So eventually we are having s raised power of 0 left. Now when we differentiate the constant, it gives us what? 0. We have established that already. So eventually, what's our final answer? Our final answer becomes what? dy over the x equals what? 6x plus what? Anything raised to the power of 0 is what? 1. So 6x plus 6. We can leave out the minus 0. Hope this is clear. Now, calculus is this easy. The only thing it requires from you is that you understand the concept involved. Alright, so now this is the basic concept of what? Differentiation or differential calculus. Like I said, in further episodes we also move into integral calculus. And moving into integral calculus, we consider the concept of integration. Integration is like the opposite of differentiation, so we still focus on differentiation for now, and in subsequent episodes here we'll also tackle some questions under differential calculus, where we have to solve more problems, at least 3 examples, and then we'll also be giving some exercises, some problems to solve on your own. Alright, now for your assignment, you just solve this. You differentiate the following functions with respect to their variables. I have explained the details, so I expect you should know what to do here. So for the first one, you know that you are actually going to find what? dt over the x. And for the second one, you know you have to find what? dy over the x. For the third one, you know you have to find what? dv over du. So that's what I expect you to do. Now forward your solutions to the link that will be attached to this video for the submission of assignments. If you are watching this video from the YouTube channel right now, you can also check for that link on the description, where you can submit your assignment to. And remember that an award goes to the person or the student who submits the assignment most for this month of April at the ending of the month. Now please, before you go, don't forget to subscribe to this channel. Very, very important. If you have watched this lecture, you are really sure you enjoyed it, make sure you subscribe to this channel. Subscribe, and please make sure you share this video to at least 1 or 2 of your friends. Then also hit the like button, like the video, and that's it. So before we go, I just want to remind you that Jesus loves you and is coming again. Even as students, our students will not be exempted from the rapture. When rapture takes place, students will also be part of it. So if you are not prepared, it's not meant for mommy and daddy alone. Even students too need to be saved and get ready for heaven, because when the rapture takes place, everybody will stand before God in the time of judgment after everything is wrapped up. So you give account for your life. So how are you living your life right now? Are you saved? If you are not saved, it's very dangerous. So don't forget to include Jesus in your life, even as you solve mathematics. Alright, see you in our next episode. Stay blessed.